So far, we have discussed about motivate function. We in fact talked about how we can partially differentiate motivate function with the use of the partial differentiation techniques. Now, we can as well integrate motivate function, and that is the main purpose of this video. In this video tutorial, you will learn how you can integrate motivate function with respect to any of the independent variables. What you need to know is that the process at which we integrate motivate function, we call it double integral. So that is the main topic of this video. So it's being expressed this way. Given that you have the integral from y1 to y2 to be attached with the integral from x1 to x2 of f of x, y, where the function is the motivate function with respect to x and with respect to y. This is how all problems you will be coming across in relation to double integral motrices, though sometimes it may be scattered. Well, we'll cover that in this video as well, so you can know how you can rearrange it or probably make things work out perfect for you. So what does this mean next year? That's what we actually need to pay attention to. Usually what I like to do personally is that I usually bracket this, or probably you can just separate it using a block. Okay. So you see that expression we have inside the box. You want to integrate that function. You can see the function is a motivate function, f of x, y. So it will be a function that will have x time and y time. You want to integrate it with respect to x. You can see dx. Now, having done that, you will plug in the integration limits, the x1 and the x2. For you to be watching this, it means you should be familiar with the names of the integration. So we'll plug in this one inside our result after integrating. We also plug in this one inside our result after integrating and then subtract the two from themselves. It should basically be x2 minus x1. Perfect. Now, having done that, you will now take your new result and then integrate it with respect to y again. It should now be from y1 to y2. You are dealing with definite integral also. You now take whatever result you have here. Okay, let me say this capital letter f of x, y, or let me say this g of x, y. Okay, because it will be a new function g of x, y. Then you now integrate it with respect to y. Now, usually in most cases, by the time you get to this point, that function would have ended up being a univariate function. What I'm saying makes sense is that it might not be including x term anymore. It might just be g of y. And so that at the end of the day, you will have a result, you have a value. Is that okay? By the time we consider the example, you will see what I'm saying makes sense. I'm just giving you an instance. It might be a motivate function sometimes, and sometimes, which is most times, it might not be a motivate function. It might be a univariate function. It might just be g of y. So from y1 to y2, g of y to y. So basically integrate g of y again and then evaluate it with respect to the integration limit. And that's all. You have your answer and you have been able to provide a solution to that problem. Am I communicating? So that's what makes sense. Now, for you to actually put this into good use for a better understanding, let's consider an example problem. So this can go. So let's say we are required to find the integral of this double integration. Integral from 1 to 2 and the integral from 2 to 4. Then the function is x plus 2y. Then we have the x to y. Am I communicating? So if the s comes first right here, we can clearly say that this is the limit that corresponds to the x. That again. So you can probably bracket this. And if you don't want to do that, you can just box it. Just for you to not end up substituting the wrong limit of integration in the wrong final expression. I will get my points. So let's basically pay attention to this one. So instead, I will put it in a bracket and have the integral from 1 to 2, then a bracket, the integral from 2 to 4 of x plus 2y dx, and close the bracket, the y. So it means whatever I have here, I will now integrate with respect to y again. Perfect. So what will be this one? So let's do that. So that will be equal to the integral from 1 to 2, and the bracket. So we are integrating with respect to x. You will treat y as a constant. Is that okay? You will treat y as a constant, just as if you are differentiating using the concept of partial differentiation. Because we are going to treat it as a constant. And pay attention to this one again. Now integrating x with respect to x, that will be x squared over 2 plus. Now 2y we are treating as a constant. If we integrate a constant, what will be our result? We will attach x to it. Perfect. So that will be plus 2xy evaluated from 2 to 4, and then we are integrating at the end of the day with respect to y. So let's add one more step. We have integral from 1 to 2 in a bracket. Now we can just do the math. Let's plug in these values for x and then subtract. So remember, the upper one is the one that will come first, while the lower one will come after. It is the one that we are going to subtract from the upper one. Okay, subtract from the lower limit from the upper limit. So we have 4 squared divided by 2 plus 2 times 4 times y minus in the bracket 2 squared divided by 2. Okay, then plus 2 times 2 times y. Excellent. Then close the bracket. We are integrating the entire result with respect to y again. Well, we are proceeding. Let's move forward. So now the next step is to evaluate what we have here. So we have the integral from 1 to 2 in the bracket. 4 squared is 16 when we divide it by 2 is 8. Remember, 4 squared is 16 by 2 is 8, right? Plus 2 times 4 is 8 times y is 8y. And minus in the bracket. 2 squared is 4. I'm here now. 2 squared is 4. 4 divided by 2 is 2. Plus 2 times 2 is 4 times y is 4y. That's 4y. We close the bracket. And then we have the function. So we are integrating with respect to y again. Alright, now we have integral from 1 to 2. Big bracket. Now basically we need to distribute this minus sign. And then we have 8 plus 8y. From minus 2 minus 4y. Okay. Then with respect to y again. Now this can go at this point. We are moving forward. Excellent. So integral from 1 to 2. Big bracket. 8 minus 2 is 6. 8 plus 4y. No, plus 8y minus 4y. That's plus 4y. Perfect. Plus 4y. And close the bracket with respect to y. This is what I'm saying makes sense. Now look at it. This is now the function we have left over. Tell me, is this function a multivariate function or a univariate function? Clearly, you can see that it's a univariate function because there's no more extra. So it's a g of y. Perfect. That's what I'm saying. That at the end of the day, you might not have x anymore. If you have x, why you want to differentiate integrate with respect to y? Treat that x term as a constant. Simple as that. Is that again? Perfect. So we have equal to, now basically we want to integrate what we have right here with respect to y. And thus that will be integral of 6. 6 is a constant. If we integrate with respect to y, we just need to attach y to it. 6y plus then integral of 4y squared, that will be 4y, sorry, 4y is 4y squared over 2. Evaluated from 1 to 2. Okay, perfect. Now we have 6y plus 4 over 2 is 2y squared, evaluated from 1 to 2. Perfect. So let's plug in the limit of integration and have our final answer to this problem. So now if you plug in the limit of integration, the upper limit is 2. So we have 6 times 2 plus 2 times 2 squared, okay, minus the bracket 6 times 1 plus 2 times 1 whole squared. Then we can close the big bracket. Perfect. So now this can go, and then we have it to be equal to 6 times 2 is 12, plus 2 squared is 4, 4 times 2 is 8, minus the bracket 6 times 1 is 6, plus 1 squared is 1, times 2 is 2, plus 2, and then we can have 12 plus 8, 6 plus 2 is 8, and we do that, and finally this can go, and then we can have 12 as our final answer. And that is the double integration to the problem we looked earlier. So guys, this is how you can easily integrate an integrated function. This is how you find it helpful, and that's the kind of thing. Let's consider a few more example problems so you can develop your understanding of this idea to full potential. By the way, feel free to pause the video and try this one out if you would like to do so. So we are required to evaluate the integral from 1 to 2 attached with the integral from 0 to 3 of x squared y dx dy. So just like before, let's isolate this. So we can try solving this first. And for that to be possible, we need to bracket this. So this can be expressed as the integral from 1 to 2 in the bracket, integral from 0 to 3 x squared y dx, and the brackets will close. Again, we have the y. So basically, we will integrate this function. It's a multivariate function because we can clearly see that it has x squared and y being attached together. Alright, so how do we integrate? Remember, while integrating with respect to x in the first place, you have to treat that y as a constant. And if you are doing the other way around, that is, if you are integrating with respect to y, you have to treat that x term as a constant. Please make sure you don't forget that process. This is simply equal to the integral from 1 to 2 the bracket. Now we basically need to integrate this one, consider this to be a constant, so that will be x cubed y divided by 3. Another complication, basically I pay attention to this because if this is like a 2, then it should be like 2x squared, and if you integrate 2x squared, that should be 2x cubed over 3. Is that okay? So that's how we got x cubed y over 3. Now clearly we need to plug in our integration limits. So that is from 0 to 3. When we close the bracket, we have the y. Now let me try to clarify one thing. You really don't need to add the plus c, the constant, because this is a definite integral. Double integral is actually related to definite integral. Okay, and in definite integral, at the end of the day, the constant will cancel out. So there's no need actually writing it, because at the end of the day, it will still vanish. So this is now equal to, so that's why I'm not putting the constant, for those who might be curious about that. So integral from 1 to 2 in the bracket. So now basically we plug in 0 and 3 in the expression and subtract our result. Remember, it is this one minus this one. So let's plug in 3 first. So that will be 3 cubed times y divided by 3 and minus 0 cubed times y divided by 3. And close the bracket. We are now integrating with respect to y. So this can go. Then we have our integral to be equal. So the integral from 1 to 2 in the bracket. 3 cubed is 27. Y over 3. The 0 cubed is 0 times y divided by that. That has gone with respect to y. So I can actually write it in front. 3 in 27 is 9. Then we have the integral from 1 to 2 of 9y with respect to y. So basically we need to integrate this. Now as you can clearly see with this problem, we end up having a univariate function at the end of the day. So that is something to know. So that's now equal to, now what will be the integral of 9y with respect to y? That will be 9y squared divided by 2. Well, some people might say, well, how do we integrate? The integral of x with respect to x is simply, let's say x to the power n, where n can be any index. It could be a negative value, it could be a positive value, in fact, it could be a fraction. Especially n can be a real number. So the integral of this is simply x raised to the power n plus 1 divided by n plus 1. Since this is not a definite integral, we need to put plus c to it. But a definite that has integration limit probably a to b, you don't need this because this will cancel out. I'm not going to make it perfect. So if that is the case, if I should apply these techniques to this 9y, integral from 1 to 2 of 9y to y simply means, I have to pay attention to the variable because y is a constant. So there's an invisible one here that's telling us that y is raised to the power of 1, though it's not necessary to write it. So that's why it's not often written, because seeing it there is not of no use. Yeah, it's of no use. So now we basically need to add 1 to these and add 9 times y is 1 plus 1 according to the rule. Okay, then divided by 1 plus 1. This is 1, not 7. As you can see, that becomes 9 times y squared over 2. And that's how I end up with this one. So that's how you can easily integrate functions. So remember, we are integrating from 1 to 2. So now we need to plug in the values. The upper limit will come first. 9 times 2 squared divided by 2. And minus 9 times 1 squared divided by 2. It's a square. 2 squared is 4. Well, I can quickly reduce that with this 2 and have 9 times 4 divided by 2 and minus 1 squared is 1, 9 over 2. So this reduces this, that becomes 18, right? Then I have this will be 2, right? 2 times 9 times 2 is 18 minus 9 over 2. Am I communicating? So let's do that. We need to find LCM. Oops. That's a big problem. We would have instead find the LCM right here. Right? Well, the choice is yours. I didn't observe that this is true. Okay, we should have find the LCM so that we don't need to multiply it again. Okay. Let me reverse the process. That will be the best. So I don't want to cancel anymore. I don't want to cancel because I want to find the LCM, right? So that will be equal to 9 times 4. That would gives us 36 minus 36 over 2 minus 9 over 2. Okay, now since the denominator of two fractions are the same, we can take one and just subtract the numerator. 36 minus 9. 36 minus 9, that will gives us 27. Clearly, it implies that our final solution is 27 over 2. And that is simply the double integral to the problem number 2. So guys, this is how you can easily find the double integral of a multivariate function. So by now I want to believe we should have been getting used to the techniques and the logic. So let's consider one more example problem before we end the video. If you're here to subscribe to this channel, feel free to subscribe. If you're enjoying the video, you can leave a like so you can recommend it to many audience out there. So we have the integral from 1 to 2, integral from 0 to pi of 3 plus sine theta, the theta, the r. Okay. Now feel free to pause the video and try this one out yourself if you'd like to do so. Now some of you might be wondering, so far we have been discussing about the x, the y. This is now the theta, the r. Well, it's just a change in letters, change in variable. It doesn't have any impact in the process. But I'm communicating. The process doesn't remain unchanged. It's just that the variables is what is going to change. So basically, we need to pay attention to this one first. That's what I've been doing right from start. So that will be equal to the integral from 1 to 2. Then bracket, integral from 0 to pi, and 3 plus sine theta, and the theta, the r, etc. So basically, we're going to integrate this. So that simply equals to the integral from 1 to 2 of, now, this is a constant. So what is the integration of 3 with respect to theta? That will simply be 3 theta. Remember, if it is with respect to x, what would happen to become 3x? Now be careful here, though there's no arc time here. You understand? But if at all there's arc time, you will treat that arc time as a constant too. Is that taken? You treat it as a constant. Though it's a variable, but it has to be treated as a constant. Is that taken? Also, you are integrating with respect to x. So therefore, that's why we are with respect to theta. So therefore, how should have no business with that. Is that taken? Perfect. So now, what is the integral of sine theta? Now remember, the derivative of cosine theta is negative sine theta. So in the sense, antiderivative and derivative are inverse of themselves. It means the integral of sine theta will be negative cosine theta. Thus, we will have 3 plus in the bracket minus cosine theta. And now calculating, now the limit of integration is from 0 to pi. Then we close the bracket, and then we get rid of this one and put the r, etc. Are we together? Perfect. Thus, we now have the integral from 1 to 2 in the bracket. So now let's plug in the integral limits. So we have 3 times theta plus, sorry, I said theta, 3 times pi plus, okay, let's do this math. Plus times minus will be minus, okay? So I don't really need to put plus anymore. I'll just put minus cosine pi. Okay, remember, we are not subtracting the lower limit from it, minus the bracket, 3 times 0. This is minus, remember, minus cosine 0. Excellent. Remember, we will now take our result and integrate it with respect to r. Perfect. So, on to our next step. This will now be equal to the integral from 1 to 2 in the bracket. Now 3 pi is still there, 3 pi, and minus cosine pi. Pi, the angle is measured in radian. Pi corresponds to 180 in degree. Okay, from radian to degree, it corresponds to 180. And the cosine of 180 degree is minus 1. So this should be minus 1. And we have minus in the bracket. Remember, these values are for the lower bound or the lower limit. 3 times 0 is 0 minus cosine of 0 is 1. And we close the bracket. We are seeing integrating with respect to r. This can do as well. Now, excuse me, we have the integral from 1 to 2 in the bracket. 3 pi minus 1 times, sorry, minus times minus 1 becomes plus 1. Then 0 minus 1 is minus 1. And that minus 1 times this minus becomes positive 1. Perfect. Plus 1. And then with respect to r. So something inside the bracket. That's not equal to integral from 1 to 2 of 3 pi plus 2 with respect to r. So basically now, we need to integrate this expression with respect to r. Perfect. So that will be equal to, since we are integrating with respect to r, 3 pi is a constant itself. So if we integrate with respect to r, we have 3 pi r plus 2 is a constant also. If we integrate with respect to r, we have 2r evaluated from 1 to 2. Am I communicating? Perfect. So right now we just need to plug in the integration limits. So let's do that. If you want, you can factor out r to make things much more perfect for you. And if you don't want, you can just probably substitute these values. But let's factor. So since r is common, we can bring it out and have 3 pi plus 2 then from 1 to 2. So now plugging in the limits, we have 2 times 3 pi plus 2 minus 1 times 3 pi plus 2. Okay, so basically, this becomes 2. And plug in r as 2 and r as 1. Excellent. So now, this is 2, 3 pi plus 2. This is 1, 3 pi. We can subtract one of them. We can subtract, remove one, and then the final answer to the problem should be 3 pi plus 2. And that is the solution to the problem. Am I communicating? So guys, I want to believe you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now. So this is the exercise I have for you. Consider finding the integral of the double integral from 0 to 2 attached with 0 to 2 and pi over 2 of 5 cosine theta dx. So thank you once again. Bye for now. See you in the next video.